Hey guys, this is Unit 5, Lesson 8, Comparing Distributions, and I have an active migraine, so let's see how this goes. Let's do a quick review. Symmetric distributions are when a graph has a line can be drawn straight through the middle to create two mirror or symmetric images. I've always described this as being able to fold the graph in half and everything lines up perfectly, or like when you fold a paper in half and draw half a heart and then cut it out, you have a perfectly symmetrical heart. In a perfectly symmetric distribution, the mean and the median are located at the same point, the exact midpoint of the distribution. So if you find one, you automatically know the other. For histograms, the numbers on the horizontal axis, which is this one on the bottom right here, may show a range of values that are included in each bin. The number on the left side of the bin is included in that bar. The number on the right side of the bin is not included in that bar, but rather in the next one. So if I had the value of 12, it would be in this bar. 12, 13, 14, 15, 16, and 17 are in this one, but if I had 18, it's going to go into this next category right here. Suppose that customers leaving a pet food store were asked how much they spent on food for their cat or dog each month. The results were compiled into the histograms. Both histograms have a symmetric distribution. You can see that because they're balanced on each side exactly. Okay. The histogram for dogs has a larger range. You can see it goes from 6 to 44, while cat food only goes from 12 to 42. You find the range by taking 42 and subtracting 12, which is going to give you a difference of 30. If you take 44 and subtract 6, it's going to be a lot bigger number than 30. So this has a bigger range. By adding together the height of each bin in each distribution, you can find the total number of people who responded. That means here in this bin, there were 4 responses. In this one, there were 8. So you would add 4 and 8 together to get 12. Then you would add, I don't know what that number is, maybe 11, and then all the way through to get your total number. So 34 people responded regarding cats and 32 people responded regarding dogs. Okay, you get those by coming over here to the y-axis, figuring out how many are in each bin, and then adding it all together. The mean and the median are both in the center bin for both histograms. Okay, so this is where the mean and median is located for this one. This is where the mean and median are located for this one. They cannot be determined exactly because with a histogram, we don't have individual dot points that tell us the exact amount. We don't know, like in this range between 24 and 30, we don't know if there was like a 24, a 25, and 3 26s. We don't know the numbers in here. We can only estimate what the mean and median are. The mean and median are between 24 and 30. Okay. The mode for each distribution may or may not be in the center bin. It is not possible to determine a mode if the interval corresponding to the bin can contain more than one number. So there might be like 8 19s, we'll say, 8 19s, and there might only be one of each number in here. Even though this has 8 responses and this has 6, I guess there can't be 9 in here. There might be 6 and they might all be the same number in here. And these might all be different numbers. So the mode could be here, okay? If you don't have individual dot points, like on a dot plot, you can't make specific determinations on these. With a histogram, you're never going to know what the mode is unless you have like the actual number set list, okay? Here's a check-in. Which 2 measures of central tendency are always found in the center bin or precisely between the 2 center bins of a symmetric histogram? When they say precisely between the 2 center bins, they mean the middle 2 would be the exact same height. And then if it's symmetric, you would have like matching on the outside. But you could have 2 in the middle that are exactly the same. Okay. So which 2 measures of central tendency are always found here or in this one central? Okay. The mean and the median. With histograms, you can't know the mode. Remember that. Okay. Here is a symmetric box plot. The median is at exactly the center of the plot. This is the median. Okay, and it's in the exact center of the box because we're dealing with symmetric. Both whiskers are evenly spaced from either side of the box, so they're the same length. Okay. The mean is located at the same place as the median. Because it's symmetric, we know the mean and the median are the same. With a dot plot, this is what a symmetric dot plot looks like. Now this one looks different than the others. The others were all bell-shaped curves, so they were, I gotta change my ink color or it won't show up. They were all like this except symmetric. Okay, this one is a U-shaped curve except symmetric. Okay, this is still symmetric. If you fold it in half, everything is still gonna line up exactly. Okay. Mean and median are both at the same value, 5. They're still here. This becomes the central balancing point instead of being like the highest number of responses or whatever. There are 2 modes in this. Mode is the number that happens the most often, and that occurs at 3 and 7 because they have the same number of dots. Okay, so there's 2 modes for this one. Symmetric distributions must have the mean and median located at the same point. That's always going to be that, okay? You're never going to have different mean and medians when you're symmetric. It's not necessary to know the mode to determine whether a data set is symmetric or not, okay? Mode does not have anything to do with it being symmetric. Here's another check-in. In perfectly symmetric distributions, what are always found in the same place on the histogram, dot plot, or box plot? The mean and the median. Here is example number 1. You are working on a science project for school. You're investigating this question: does doing homework affect test grades? You have compiled data from your class and arranged it into the following 2 plots. Using the symmetric box plots, compare the distributions. You can tell looking at these that these are symmetric, but it's also told us it's symmetric, so we can just go with that. Although both box plots are symmetric, they give very different results. The average test grade or mean for students who do not complete their homework is at 55, while the average grade for students who complete their homework is at an 80. That's a big difference, okay? The lowest and highest scores for each group are also different. You can see that here, okay? With grades generally being much better with students who do most of their homework, which makes sense. If you do your homework, you're going to score better on the test. The range of grades for students who do not complete their homework is 60, and that's the range from 25 up to 85, okay? While for those that completed their homework, the range is 40, from 60 to 100. Not only do the students who do their homework generally get better grades, but they also have more consistency in their results. They have a smaller range, they're going to score higher, and have less room for error, I guess is how you would put it. I mean, like, if you don't do your homework, you might score clear down at 25, or you might get lucky and score clear up at 85. Whereas if you do your homework, you might score clear down at 60, or you might score up at 100, okay? Here's question number 1. This one is your turn. Individuals from several families were surveyed and asked how many minutes they spent each day doing household chores. Box plot 1 summarizes the responses from adults, and box plot 2 summarizes the responses from teens. Are the distributions symmetric? How are they different? Pause it, figure it out, come back. Okay. Looking at these box plots, you can see that they are not symmetric. This midpoint is over to this way more than it should be. Okay. If you folded right here, these would not match up. This would end up being the fence on this box would end up being short. You can also see that these whiskers are not the same length. Okay. Same with this one. It's pulled more to the right, this center line on the box, and you can see that this whisker is longer than this one. So they are not symmetric. Okay. And then it wants to know, how are they different? For both box plots, the whiskers on either side of the box vary in length, therefore they're not symmetric, and the mean is not determinable from the box plot alone. They have different medians and maximum values. So you can see here their maximum value for box plot 2 is 15, and the maximum value for box plot 1 is 25. I wish I only spent 25 minutes a day on chores. Psh, gosh, what would that be like? Okay, question number 2. So individuals in 2 different cities were asked how many miles their home is from a grocery store. The responses from the first city are shown in histogram 1, and the responses from the second city are shown in histogram 2. Examine the histograms. Remember that the left number on the bar is included in the range of values. For example, the first bar in the histogram includes values from 4 to 4.9, or very close to 5, but not including 5. Are the distributions symmetric? How are they different? How are they similar? Pause it, figure it out, come back. Okay, so if you look at these, you can see that they are symmetric. If I folded this right here in half, each of these is going to line up, okay? Same with this one. Both histograms have a mean and median in the range 7 to 8. So those match, okay? They have similar range of values, 4 to somewhere above 10. I can't read that, it's small. Same over here, okay? They are different because they are both from different shapes in their distributions. This one is kind of like a W, and this one is a traditional bell curve, okay? So they're representing different data, obviously, okay? Here is practice question number 1. This is at the end of your lesson, so you'll want to write this down so that you can enter it later. Compare the graphs that summarize the quiz scores for Class A, Class B, and Class C. All 3 classes had symmetrical data sets. Another student from each class will take the quiz. Which answer best describes which student's score will be easiest to predict? Okay, so we're going to kind of walk through this one together because there's so much information I couldn't fit it on one slide. So here's your first option. It says the score for a new student from Class B will be easiest to predict. The score will be either 60 or 80 because the range and IQR are the same value. So first, let's figure out the range. The range is 80 minus 60. So range is equal to 20. Now let's figure out IQR. Now you should have the formula for IQR in your notes. If you don't get it in your notes, you need this. So IQR is equal to, Q3 minus Q1. So the way I figure out Q3 minus Q1 is I would do a 5-number summary. So our minimum is 60, our maximum is 80, our midpoint between 60 and 80 is going to be 70. So midpoint between 70 and 60 is going to be 65. So that's Q1, okay? And the midpoint between 70 and 80 is 75, so that's Q3. So IQR is going to be 75 minus 65, which is going to be 10. So is this a true statement? Because the range and IQR are the same value. That one's eliminated. Let's go to the next one. The score for a new student from Class C will be easiest to predict. It is likely that the score will be greater than 77.5 because the maximum value in this set is the greatest. Okay, so let's pick it apart bit by bit and let's start with the easiest. It says the maximum value in this set is the greatest. So somebody scored like between 93 and 94 in this. Let's come back here and see what the other high scores. This is in the 70s. Are we dealing with Class C? Yes. Okay, which is going to give us our 93-ish. And then this one has something in the 80s. So it is the highest score, so that could possibly be right. But it says this is going to be the easiest to predict because the score will be 77.5, which they say is going to be right about here. Okay. Now, I'm not entirely sure why they think we can predict what this student's score is going to be, because there's really no predicting. I mean, we have this whole range that it could reasonably be if they were in that class. So I guess this one is a possibility. Let's go to the next one and see if we can eliminate it. The score for a new student from Class A will be easiest to predict. It is likely that the score will be within 6 points of 70 because the IQR and range are relatively low. So here's 70. It says it's going to be within 6 points of it. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6. Okay. It's gonna be within that because everybody's scores are within that. So this one makes the most sense to me without even figuring out what the IQR and range are. But let's figure it out just to be sure. So the range is between 74 minus 66, which is going to give us 6 and 14, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 8. So the range is 8. That's a low number. And the IQR would be minimum, maximum, halfway between those two, 8, so like 4, 60 would be 70. Halfway between these two would be 68. And then halfway between these two would be 72. So it would end up being 72 minus 68, which is going to give us 4. So yeah, they're both low. I'm going to say that this one would be the correct answer. That's what makes the most sense to me. Because this, I just don't know how you could say somebody's going to score right there when you have this whole range. And when this and this are the most likely place for them to score. This makes the most sense to me. If I'm wrong, let me know, because, I could be. Here's practice question number 2. 3 different classes took the same math quiz. The scores are summarized in the graphs for Class A, Class B, and Class C. Which statement best describes the class that had the greatest variability in the quiz scores? Again, I couldn't fit it all on one slide, so we'll work through this together. Who had the greatest variability? So this one says Class B, which is right here, had the greatest variability because its range and IQR were greater than Class A. So we're going to have to blow this up so I can see what we're dealing with here. Its range is going to be 80 minus 60, which is 20. Okay. And what was the other thing? I'm guessing it was the IQR that it wanted us to look at. Yep. So let's figure out the IQR. It's going to be minimum, maximum, midway will be 70, midway between these will be 65, midway between these will be 75, so 75 minus 65 to find the IQR is going to give us 10, so the IQR is going to be 10. Okay, so there's our first one. Let's put him away and let's look at the next one. Okay, get big for me. Okay, let's erase some of this stuff that we don't need, like you and all of this. So the range for this first one, we'll write it over here so I don't get confused, is 76 to 65, which is like 11. Okay. And the IQR is going to be, we have 65, we have 76, so halfway of 11 is going to be 5.5, so 65, 66, 67, 68, 69, 70, so it's 70.5 here. And then halfway between here is 5.5, so that's going to be 2.25, so 67.25, something like that. I'm probably doing this wrong because I'm not the smartest person. 70, so half, 5.5, 2, oh no, 2.75, so this should be 75, sorry, 2.75, so that would be 72 plus 3/4 will be 73.25. Woo! So I'm just getting my calculator for this. 73.25 minus 67.75 gives us 5.5. So the IQR here is 5.5. Now, what's the statement that it's making? Get small for me, dude. Yep, get small for me and come over where we can see you. So Class B had the greatest variability because its range and IQR were greater. Range is greater, IQR is greater. So this is a possibility. Okay. Class A had the greatest variability because it had 5 students who received the same scores. That is a true statement, but that doesn't have anything to do with variability. That's the mode. So this one makes no sense. Okay, mode has nothing to do with variability. That actually decreases variability for people that have a whole bunch of the same score. Okay, classes A, B, and C had all the same variability because they are all symmetrical data sets. Well, we already know that these two had different variability, so this one's out. So we're going to go ahead and say that this one has to be the correct answer. Okay? Oh, wait, there's one more. Class C has the greatest variability because it had the greatest range and IQR of any class dataset. Wait. Before we say that this is it, we need to figure out Class C. So its range is 93 minus 62. Calculator time. 93 minus 62 gives us 31. Okay, range equals 31. Well, already we can go back and look and see that its range is the biggest. So this one is going to be the correct answer. Class C. All right. This is practice question number 3. Class A and Class B took the same math quiz. The scores are summarized in the histograms for Class A and Class B. Which statement best compares the scores of the two classes? So pause it, figure it out, come back. All right, the range of quiz scores is greater in Class B than in Class A. So let's look at the ranges. We have 60 to 80, so the range for Class B is 20. The range for Class A, I need to blow it up because I have old lady eyes, is from 65 to 76. We already know that's Class A is not bigger. So it says the range of quiz scores is greater in Class B than Class A. That is a true statement. So this is probably it. Let's continue. The mean quiz score is much greater in Class B than Class A. So the mean is the balancing point, which is right here at between 68 and 70. And for Class A, it's between 70 and 71. So it's Class B was not higher. This one's out. The scores in Class A are symmetric. That's true. But the scores for Class B are not. That's also true. Wait, nope, because this is the balancing point. No, it doesn't look symmetric because if we fold right here, these are going to match up, but these two are not. So this is also a possibility. Only Class A has a median quiz score. That's not true because they both have a median. It's just that this one is U-shaped and this one is bell-shaped. So it has to be one of these two. The range of quiz scores is greater in Class B than in Class A. That is a true statement. The scores in Class A are symmetric, but the scores for Class B are not. These are both true statements. I wonder if I made a typo somewhere. This is interesting because you would fold, let me change my ink color, right here, shink, which means that these two line up, but this one is going to be in this gap right here, and this one is going to be in this gap right here. I guess, and this doesn't count against your score. So, and see which one they want. And then, comment and let me know because this kind of stuff irritates me. This is quick check question number 1. You do get graded on this, so I won't give you the answer. I mean, I didn't give you the answer last time, so compare the box plots summarizing the test scores of students who completed their homework versus those who did not complete their homework. Which statement is true? So you're going to go through these and figure out which one is true. All students who did not do their homework, which is here, scored below 70%. So did they all score below 70? All students who completed their homework scored higher than students who didn't. So these people that all did their homework, did they all score higher than those who did not? No student got a perfect score on the test. Is that true? On average, students who completed their homework scored higher than students who did not. So on average is this box plot or this center line, is either way you can look at it. Did people who did their homework score higher than people who did not? I believe in you. Quick check question number 2. Compare the box plots summarizing the test scores of students who completed their homework versus those who did not complete their homework. What was the lowest score among the students who did complete their homework? So we're not looking at this one. Okay, we're looking at the ones who did complete their homework. What was the lowest score? Go ahead and pick it. This is the second half of the lesson, skewed distributions. The best measure of central tendency is the median. That's what we focus on because these outliers can screw it all up. This chart shows data skewed to the right, which means the data is clustered on the left. The dinosaur's head is here, and the chart tails off to the right. His tail is over there. Okay, so when you're saying is it left or right skewed, what matters is the tail. Don't forget that. That's the important bit there. Now, I didn't remember at all how to find mode, and we have to, so I'm guessing you needed a refresher too. It's the number or numbers that appear most frequently in the set, and it requires the numbers to be in ascending order so you can see, oh, there's 3 7s or there's 2 19s. That's the mode, okay? Here's a check-in. One histogram is left skewed and another is right skewed. Assuming that the scale on the horizontal axis of the 2 histograms is the same, which has a higher median? So stop and think about it. Left skewed means the tail's on the left, and right skewed means the tail's on the right. Which one has a higher median? Left skewed, because the head, most of the data, is over on the left. That is the best arrow I've ever drawn. Here's example number 1. Using the skewed box plots, compare the distributions. Give the 5-number summary as well as the spread in the comparison. So we need the 5-number summary and the spread. Okay. You are running a nacho stand at your school's festival. You're trying to decide whether you will earn more money operating the stand right after school until 8 p.m. or from 8 p.m. until the festival ends. You have sales data on the number of customers from previous years and have arranged it into 2 box plots. Is it more profitable to operate the nacho stand before 8 p.m. or after 8 p.m.? These box plots are both skewed. You can tell that because like this one has a super long whisker here and this one has a super long whisker here. Both of them look like the median is pretty centered in the box, but you have to have both be balanced or else it's skewed, okay? The data for before 8 p.m., which is this top one, is skewed to the right because it has the dinosaur's head here and then the tail. And the data for after 8 p.m. is skewed to the left. We have the tail here and then the head. Okay. The 5-number summary for the box plot before 8 p.m. is 10, 20, 30, 40, 70. 10, 20, 30, 40, 70. The 5-number summary for the box plot after 8 p.m. is 20, 50, 60, 70, 90. The range for before 8 p.m. is 60, which is between 10 and 70. And the IQR is 20. The range after 8 p.m. is 70, 20 to 90, and the IQR is 20, which is this 50 to 70, okay? The IQR for both is 20 customers, okay? So the IQR is the same. The range after 8 p.m. is 70. When both IQRs are 20, that means the consistency of the middle 50% will be less relevant to the comparison to the central tendency. That's not going to help us figure out which is more profitable, so we can ignore that. Because these box plots are both skewed, the best way to determine which time frame will be more profitable is to find the median for each, as that is the best measure of center. And here we have a median, and here we have a median. That means the median for the data before 8 p.m. is 30 customers, and the median for the data after 8 p.m. is 60 customers. So the skewed nature of this data reveals that there are more customers after 8 p.m., so it's more likely to be more profitable to set up your nacho stand after that hour. Okay? Another check-in. 2 box plots have the same median. The first box plot has a much greater difference between the maximum and Q3 than the difference between the minimum and Q1. The second box plot has a much greater difference between the minimum and Q1 than the difference between maximum and Q3. Which box plot is skewed right? Did you blank out on all that like I did? Because that's just too much for my brain to do. We're going to draw it. The first box plot has a much bigger difference between the maximum, so here's the maximum, and has a big difference between maximum and Q3. Here's our little box plot, and then we'll put whatever because none of this matters. And then the difference between the minimum and Q1. Oh, I did it right. Okay. The second box plot has a much greater difference between the minimum and Q1 than between the maximum and Q3. Okay, so these are the 2 different ones. Which box plot is skewed right? Wherever the box is where the dinosaur's head is, and then we go down to the tail. Which one is skewed right? The tail is the only thing that matters, so it's the first box plot. This one is skewed right. Here is example number 2. A bookstore started selling sweatshirts. Its employees decided to track how many sweatshirts were sold over 2 consecutive 7-week periods. The dot plots display the number of sweatshirts sold over each of the 7-week periods. Compare the 2 dot plots. So they want us to just interpret the information that we've been given here. The dot plot for the first 7-week period is skewed left. Head, tail. Okay. The mean is 5 right here. Oh my goodness. It doesn't want me to draw. It's too close to the bottom. And the mode is 6. We'll put the mode in a square. Okay. You can conclude the most sweatshirts were sold in weeks 5 and 6. The dot plot for the second 7-week period is skewed right. Head, tail. The mean is somewhere about 3. The median is also 3, and the mode is 1. You can conclude that most sweatshirts were sold in the first 3 weeks. More sweatshirts were sold in the first 7-week period than the second. We sold more here than here. Most of the sweatshirts in the first period were sold at the end of that period. Most of those sweatshirts in the second period were sold at the start of that period. You can see that very plainly and easily. Here's example 3. The ages of students in an Algebra 1 class and in an Algebra 2 class are shown in the following histograms. Compare the 2 histograms. So again, we're just interpreting what we see here. First thing I would do is look, and these horizontal axes are exactly the same. 14, 15, 16, 17, 14, 15, 16, 17. That makes it a lot easier to interpret. The histogram for Algebra 1 is skewed right, head, tail. The mean is 14.76, the median is 15, and the mode is 14. You can conclude that most students in the class are 14 or 15 years old, which you can clearly see right here without doing any math. The histogram for Algebra 2 is skewed right. The mean is 16.2, the median is 16, and the mode is 16. You can conclude that most students in the class are 16 or 17 years old, which you can clearly see right here. The typical Algebra 1 student is about 1.5 years younger than the typical Algebra 2 student. Question number 1, your turn. Compare the 2 histograms in the image. What does the skew of these histograms indicate about their measures of central tendency? How can you tell? Pause it, figure it out, come back. Histogram 1 is right skewed, head, tail. Because the data is clustered on the left side of the chart and tails off on the right, the mean right here is greater than the median, and the median is greater than the mode. Histogram 2 is left skewed, head, tail. The mean is less than the median, and the median is less than the mode. The mean is the same for both data sets, but the medians and modes differ. The mean is both 5, okay, but the others are different. It's like a mirror image. Wow. Here's question 2. A city wants to know how often its largest beach is used during the year. It records data on how long tourists leave their cars in the parking lot during the weekends in which the beach is open. The city is looking to increase its tourism industry by adding extra parking for the busiest month. Based on these histograms, when do you think would be a good time to create temporary extra parking, and why? Pause it, figure it out, come back. So first thing, look at your scale. We've got same numbers here and same numbers here. So which month looks busier? The only way to find out for sure is to find how many you have in total all the way here by counting all of these. The median for July is 6 to 7 hours of stay, while for September it's 3. Okay, you can see that, these two right here. 3 to 4 hours of stay. This represents anywhere from 2 to 4 extra hours that cars would be occupying the parking lot in July. Since there is less turnaround of spaces, it means fewer people can come to the beach. Having extra parking spaces in July could potentially help the city increase its tourism. Okay, so, that's what it means. It's looking right here. Okay, this is the mean. Okay, and with skewed data, you're supposed to look at the median anyway. So here and here, you can see there's more people in July than there are in September. So this would be the best time to create additional parking. Practice question number 4. Compare the skewed distributions that summarize the number of points scored per player in the championship basketball game between Eastern High School and Western High School. Based on the distributions, which statement best compares the two teams? Okay, pause it, figure it out, come back. This one is, it's too small, I can't read it. I don't even know which school is which. This is, oh, this is Eastern. Okay, Eastern's on top, Western is on bottom. So Western High School won the game because they had the highest scorer of the game. Not sure what that really means, because the highest score, this is points scored per player. So the person who scored the most points was right here for Western. The person who scored the most points was much higher in Eastern. So that doesn't make any sense. So that one can go ahead and be eliminated. Canva, will you just knock it off? My goodness. I know I need you like a lot, like all the time, but I don't need you at this exact second, so stop. Okay, so Western High did not have the highest score. Eastern High did. So let's get rid of you. Shunk, you're gone. Eastern High won the game because their data is skewed right. That is a completely negative statement. It is skewed left. Okay. The Eastern High School data is skewed left. That is correct. The tail is on the left. While the Western High data is skewed right. That is an accurate statement. The Eastern High School data is skewed right. No. While the Western is skewed left. Okay, there's only one correct answer that time. Hallelujah. Practice question number 5. Same data as we were dealing before. Compare the skewed distributions that summarize the number of points scored per player in the championship basketball game between Eastern High School and Western High School. Which statement correctly compares the medians of the two distributions? So we're looking for the median this time. The median for Eastern High School is less than Western High School because they did not have the highest scorer of the game. So first of all, we know that Eastern did have the highest scorer because it's right here. So this one's out. Okay. The median for Western High School is greater than Eastern High School because they played one less player in the game. I don't know why they think that. Okay, 11. This is points scored. This is, there's no way to know how many people they played, so that's irrelevant. The two teams have an equal median number of points scored because one data set is skewed right and the other is skewed left. That makes no sense because the median is obviously going to be higher over here than it is over here. So that one's out. The median for Eastern High is several points higher than of Western High because the Eastern's data set is skewed left, which is correct. We're going to have more points here, which means the median's going to be shoved this way. We're going to have more points here, which means the median's going to be shoved this way. So this is your correct answer. Here's quick check question number 3. Compare the skewed distributions Mr. Hanley and Miss Balch gave the same algebra final exam to their class. The histograms show the distribution of the scores for each class. In which range would you expect to find the median exam score for Miss Balch's class? So again, this one is going to be left skewed. This one is going to be right skewed. The median's going to be shoved more this way for Mr. Henley's class. The median's going to be shoved more that way for Miss Balch's class. So which one of these makes the most sense? I believe in you. I believe in you. Remember, the median is the most likely score for the middle 50%, the middle of the middle 50%. Okay? So I believe in you. You can do this. Quick check question number 4. Same info. Which best compares the overall scores of the two classes? Okay. Again, here's Mr. Hanley's and here's Miss Balch's. Okay. So Mr. Hanley's class scored higher overall. Mr. Hanley's class scored higher overall. Miss Balch's class scored higher overall. Miss Balch's class scored higher overall. Well, you can eliminate 2 just looking right there. Okay. And then is it symmetric or left skewed symmetric? Or 5 students scored in the middle 60 score range. You can do this. Quick check question 5. Mr. Hanley and Miss Balch gave the same algebra test. One of the classes will get extra tutoring following the exam to help them with the topics they missed on the exam. Which class likely needs more tutoring help and why? Okay, here's your skewness, I guess you would call it. Again, this is low score, this is high score. Who needs more help? Mr. Hanley or Miss Balch? Okay, that will eliminate 2. And then is it because the class median is higher or lower? I am so proud of you guys. You did it. I'm proud of you. I'm proud of you.